All right, so let me welcome you once again to our lesson today. So we are still on the circle geometry. We are going to look at the 8 theorems. If you recall in our previous videos, we are able to go through all the 7 theorems. Okay, yeah. So as I said previously, that after we are done going through all these 8 theorems, we are going to take questions. Okay, we are going to look at how questions are being asked about these theorems. So I would want you to stay calm. Okay, follow me. All right. Yes. So let's look at the 8th theorem. But before that, let me introduce myself once again. My name is Evans. I'm still your mathematics facilitator. The name of this channel is Maths TV. Kindly subscribe to my YouTube channel. You can also get a Maths TV on TikTok. You can also follow me on Facebook. All right. Yes. So let's quickly look at the 8th theorem. So what does this 8th theorem say? So here we are talking about a perpendicular bisector of a chord. And what does it say? So when we talk of perpendicular bisector, we are saying that the perpendicular bisector that passes through the center of a circle makes a right angle with a chord in that circle. So what this theorem means is that if you draw a circle and have your chord, as you know, we've already gone through chords, part of a circle, so you know what a chord is. Okay, yes. So if you draw a chord, then you have a perpendicular bisector that passes through the center of a circle. If that perpendicular line intersects that given chord you have, then the angle between that chord and the perpendicular bisector is going to be what? Right angle. In that case, 90 degrees. All right, that is what we are talking about. Now let's quickly look at how it looks like in a diagram form. Okay, yeah. So let's take this as our circle. All right, let's identify the center O. So we are going to draw our chord. So we have this chord AB. Okay, so AB is our chord. Now we are going to draw a perpendicular bisector to pass through what? The center and intersect or cut the chord AB. All right, so we take this as PQ as our perpendicular bisector. You realize that PQ passes through the center and also intersects with what? Chord AB. So once it intersects, then we are saying that the angle formed, so that point of intersection, let's name it C. Okay, so then at C, what angles are formed there? So we are saying that we have for this right angle, but formed there. Okay, so it makes a right angle. Then we can also get another here. All right, if that's the case, then we can conclude that angle ACP, okay, is equal to angle ACQ, also equal to angle QCB, angle BCP, all they are all equal to what? 90 degrees. That's right angle to angle. So this is very, very basic. Okay, so once you realize that you've gotten this shape, okay, then you know that you are getting 90 degrees at that point where they intersect the perpendicular bisector and the chord intersect. Angle and 90 degrees angles are formed there. That's the case. Let's quickly move on to our GeoGebra software and use that one also to prove this theorem. All right. Yes. All right. So this is our GeoGebra software. Okay. So let's clear the this place. Let's make here blank. So I'll clear the x and the y axis. Okay, then I'll make here blank like this so that we can see the circle very well. All right, yes. So if I want to draw the circle, then I'll have to come here and select circle with center through point. So I will draw my circle. You need to drag it and release to any convenient radius. Okay, yes. So I'm taking this as my circle. Okay, Good. So what I'm going to do is that I'm going to draw um the chord. So I'm going to pick line segment here. So I'll draw it here. Okay, I'll click one point at the circumference of the circle like this. Then I will drag it, move to another point. Okay, let me put it here. Then click on that point. So I have my chord. So the chord is what? CD. CD. That is the chord. All right. Then we are going to draw what? A perpendicular bisector. So I will come here, pick what? Perpendicular bisector. And once I pick perpendicular bisector, what I'm going to do is that I'll just come and click on any part of the chord. Okay, the chord there. Okay, so the moment I click any part of the chord, you see that the perpendicular bisector, the line has been drawn to pass through the center. The center is A, and it has passed through what? The center, which has also what? Intersected with chord C. So we are going to find out if the angle between the chord and the perpendicular bisector will give us 90 degrees. So in that case, before that, I have to make some points. Okay, so I'll choose point. Okay, now I'll make point at where the point of intersection. Okay, I'll click there to make a point. So the point there is E, that is point E. Then I would try and make one also outside. Okay, I just want to get some points so that we get there. So I'll click here, outside of the perpendicular bisector. Okay, so once we have E as the center, we can maintain it as another point, but I still can draw one maybe outside here like this. Okay, and then we have it as G. So we have point G and F, okay, outside the circle. All right, now that we have this, then we can test if you get the right angle triangle. So I will come here, pick what? An angle. So we always draw the angles anti-clockwise direction. Okay, yes, anti-clockwise direction. So in this case, I want to get what is here. Okay, so I'll click here, I'll click C, click what? E, and then I'll click either E, okay, because it is also one point, or either I'll come to J. Wherever I click either G or E, it means that angle CEG or CEA. Okay, so you realize that we have 90 degrees. Have you gotten that? That's very interesting. All right, so let me move the 90 degrees so that you can see it clear. Okay, so you see that we have the 90 degrees for this angle. Okay, then let me try and see if I can get another one here. I'll still come and pick my angle here. Okay, set clockwise direction, so I'll click on F, click on E, and then come back to C. So you realize that that one is also giving me what? 90 degrees. Very interesting. All right, so the GeoGebra has proven. Okay, so if you want to continue, we can do the same at angle FED and angle DEA. All of them can give us. So that is GeoGebra. If that's the case, then let's end here and continue next time. My name is Evans. This is Mazvis TV. Kindly subscribe to my YouTube channel, like and share. See you next time. Bye bye.